Hi, everyone. Welcome to our Module 2, Topic 3 review. This will be the last test that we have. And so we're going to go through 18 problems. And again, please make sure if you don't need like the first couple of problems, skip to the ones that you need. I'm going through these in order. So if you're looking for problem number 17, then, go towards the end of the video. And again, always, it's good to stop, pause the video, and try to solve it yourself, and then unpause it and press play, right? So instead of just watching it and be like, sure, yeah, it's always better that way if you try and do it yourself first. You will see that your learning is much better, and your retention will be significantly increased as well. All right, so number one, here we go. The graph shows the total sales in dollars for two different events. What does the solution represent in this context? So if you think about solution, what is the solution of these two lines? The solution is where they intersect, where they cross. So that's going to be right here. So if we take a look at that on the X part, that's going to be 30. The Y coordinate is 800. So what does that mean? So remember, this is X and the Y. And notice here the axes are labeled, so in case you forget. So the X stands for the total, the tickets sold during opening night. So maybe this is for a show. There are maybe two different shows going on. Maybe they're having some kind of competition. I don't know, right? And then here is the total sales for the Y, and that's in dollars. So I guess we're in the United States of America at this juncture. So if you take a look at this, that just means that at, so both, if they sell 30 tickets on opening night, I suppose it would be better if they each sell 30 tickets on opening night. The two events will make the same amount, right? Which will both make $800, or maybe have a total sales of $800. Either way you want to write that, but yes, but this is what that means, and this is the context that they're talking about. So make sure you're looking at your X-axis labels and your Y-axis labels. That'll be probably the most beneficial. All right, number two, the graph shows the total number of bracelets made by Bracy and Letty. What does the solution represent in this context? So here again is this is where they intersect, and here's 14. So this is at 14, and this is at 10. So 14, 10, what does that mean? So if you look at the X-axis, that means that's the number of hours it takes to make these bracelets, right? And here, that's going to be the total number of bracelets made. So we can say, so this is our X and this is our Y. So after 14 hours, you can, word this better if you want to, but you need this information. So after 14 hours, Bracy and Letty would have both made 10 bracelets. All right, that's it. All right, so that's the explanation of these solutions here. And so now we're going into solving each system by either elimination or substitution. I will say for the most part, elimination is usually the way to go, especially when it's written in standard form. I would say go with elimination. If it's written in slope-intercept form, then I would say go with substitution. So elimination, there is no hard and fast rule. I'm just saying that's usually the preference. So elimination if it's in standard form. Substitution is going to be in slope-intercept form. So if you're like, well, what does that look like? Standard form is going to be AX plus BY is equal to C. So where the X's and Y's are on the same side. And slope-intercept form is y equals mx plus b. So when the y and the x are on opposite sides, something like this, then I would opt for the slope, the substitution way. All right. If you notice, x and y's are both on the same side, so it's in standard form here. And so we're going to use elimination. So if I notice here, I notice that none of the coefficients are the same. But if I multiply this bottom number by 2, well, technically -2, then I could get it both to be 6. So here I'm going to multiply the bottom by negative. The reason why I multiply by -2 is because if I just multiply by 2, that'll still be a -6. I want them to, one of them to be negative, one of them to be positive, so that I can cancel them out. Okay, so here, let me rewrite them. So here's my top equation. So -6x plus 7y is equal to 11. My bottom equation, once I multiply with -2, is going to be 6x plus 28y is equal to -46. All right, and then now we're going to cancel things out. And I notice, okay, this is exactly what I wanted. -6x plus 6x cancels out. And what I have left is, this is 7 plus 28, which is going to be 35y, is equal to 11 minus 46 is -35. Ooh, we're close. And this one, so we're just going to divide by 35 on both sides to get y is equal to -1. All right, -35 divided by 35 is -1. Now we have the y. We want to have the x part. So we're going to just plug it in either to the top equation or bottom. I'm going to go for the top equation because that has a little bit slightly smaller numbers for the most part. So again, I'm going to put that in. Let's use the green equation here, green color. So -6x plus 7. And instead of y, what am I putting in? I'm putting in -1 because that's my what I found out what the y equals, right? It's -1. Now we're just going to solve this. So -6x, 7 times -1 is -7, is equal to 11. Now it's just now turned into a two-step equation. Get rid of the plus or minus, so plus 7 on both sides. And you get -6x is equal to 18. And then how do we get rid of the -6? I hope you did not say plus 6 because it's not adding or subtracting, it's multiplying with the x. So we're dividing by -6. And we get x is equal to -3. So don't leave it like this. Always answer as a point. So our answer is going to be -3, -1. That's our answer, right? And if you were to plug this back into any of these two equations, you can always check them and see, and it should equal whatever these is. If you plug it into the top, the left-hand side should equal 11. Plug it into the left, to the bottom, it should equal 23. All right, so now what if you have a problem that looks like number 4? Like there we have decimals. Very easy way to fix that, okay? It's all we're gonna do is notice that they're all one decimal, it has a 1 decimal place. So I'm gonna multiply everything, like top and bottom, because decimals are rampant around here, it seems like. I'm gonna multiply them all by 10. Again, the reason why we do 10 is because it actually moves the decimal place over 1. If you don't believe me, try it out. If you go like 0.9 times 10, what is that going to be? Check it out. So we're going to have 9x plus 17y is equal to -10. Remember, this decimal place is right here at after the 1. So that moves over to the one decimal place to the right. So that'd be -10. Or you can just think to yourself, -1 times 10, -10, right? Same thing with the bottom, 17x plus 9y is equal to -42. Now, this looks a little bit complicated. We're like, well, 17 and 9 or 17, it doesn't matter. How are we going to get that to look the same, right? We want them to be the same. So what we're going to do here, we're going to have to multiply both of these equations. I know it's not great, but we're going to have to do it. So we're going to multiply the top by 17, and I'm going to multiply the bottom by -9. And so it doesn't matter where your negative is. Maybe you want to multiply the top by -17 instead. That's fine. And the bottom by +9, as long as the negative is on one of them, because notice they're both positive for the x. That's what we would do. All right, so let's get started. So 17 times 9. Let me calculate that out. I don't know what that is. 153. So we got 153 x plus 17 times 17. 17 squared is gonna, 17 squared is going to be 289. Oh, I should have known that. 289 y is equal to -170, right? 17 times is -10. Now we're going to do the same thing with the -9. -9 times 17 is going to be -153x times -9 times 9 is going to be -81y is equal to 9 times 42 is, maybe I could do this in my head, 378. All right. So what we're going to do from here is we're going to start canceling these things out. So x's cancel out, and what do I have left? I'm going to just write it up here. So 289 minus 81 is going to be 208. Y is equal to 378 minus 170 is going to be 208. What in the world? All right, and then so we're just going to divide both sides by 208. And thankfully, our y is just equal to 1. All that work for just 1. There we go. And now what do? We're going to just plug it in. If you want to plug it back into the top or bottom equation, you can. Or if you want to use the ones where we multiplied by 10, you can do that as well. So I normally like to use the original problems. So I'm going to go with that. I'm going to use the top one right here. So it's going to be 0.9x plus 1.7 times 1. Remember, this 1 goes in where the y is. It's equal to -1. All right, and then that's going to be 0.09x. 1.7 times 1 is just 1.7 is equal to -1. Subtract 1.7 on both sides. And 0.9x is equal to -2.7. And then we divide by 0.9 on both sides. And that's going to be x is equal to -3. So now we found the x and the y. So my point is -3, 1. Remember to put in your x first and then your y, not what you found first. All right. Okie dokie. And so we're going to move on to the next one. Oh, this one looks pretty nice. They're both the same. So it's really easy to just, I'm going to just multiply the bottom one by -1 so that I can make one of them negative. And what do I get? So I'm going to copy down the first equation here, -2x minus 3y is equal to 1. And the second equation is going to be +2x plus 3y is equal to +4. And what do I get from that? Well, my x's cancel out. My y's cancel out. So I literally just have 0. 0 is equal to 5. As 1 plus 4 is 5. Is 0 equal to 5? No. So this one, in this case, when both x's and y's cancel out, this means that, and this resulting answer is not the same. That's going to be no solutions. No solution. That's it. We're done. Nothing else to do. All right, so let's take a look at this one. So if you take a look at 6, let's use dark green here. Shall we cancel out the x's or the y's? Well, I think if we, since we've been canceling the x's this whole time, maybe this time we'll cancel out the y's because they look about the same kind of difficulty here. So I'm gonna, what can we multiply for the, what number goes into 4 and, or what number does 4 and 7 both go into? I think it's 28. So we're gonna have to multiply the top by 7. And then the bottom one will multiply by 4. And since they're both negative, I'm just going to multiply the bottom one by the negative. All right. And so here we go. Ooh, actually, you know what I'm going to do? I'm going to multiply the top by negative because I noticed I'm going to have to multiply this negative 27, and that's a bigger number. Yeah, so we'll do that. So negative 7 times 6 is going to be negative 63x. Negative 7 times negative 4 is plus 28. Well, 28y is equal to negative 7 times negative 27. So it's going to be positive something. So positive, okay, feel free to use your calculators, 189. All right. And then we're going to do the next equation right there. So 4 times 4 is going to be 16x. 4 times negative 7 is going to be negative 28y. Ooh, this looks good, right? Our y's are going to look like they're going to cancel out, which is what we wanted. And 4 times negative 12 is negative 48. Okay, now our y's cancel out, which was the plan, right? So negative 63 plus 16 is going to give us a negative number of 47 equals, and this is going to be 141. Now we're going to ask ourselves, and then again, how do we get rid of the negative 47? You got to divide, because negative 47 is multiplying with x. So we get x is equal to, I want to say 3. Well, let's just check, just in case. Yep, 3. I just want to make sure I didn't make any arithmetic errors there when I was multiplying some of these things. So x is equal to negative 3. So now we're going to plug in either to the top equation or to the bottom. Does not matter which one. And it looks, I'm going to just go with the bottom one because that has slightly smaller numbers. So let's go with the red. And so we're going to go 4. And instead of x, we're going to put in the negative 3. And continue along. Minus 7y is equal to negative 12. And this is going to be negative 12 plus, oops, not plus. I meant minus 7y is equal to negative 12. Well, I'm going to get rid of the 12 first, so plus 12 on both sides. And so negative 7y is equal to, well, what's negative 12 plus 12? People get messed up with like 0. Oh, no solution. No, there's a solution, right? And what is that going to be? So we're still going to continue because 0 is still a number, right? We still have a variable there. Like look at number 5. Remember, both our variables canceled out. That's not this situation. We still have y there. So we're going to divide both sides by negative 7. And so what is my y equal to? 0 divided by negative 7, which is y is equal to 0. So my point is going to be negative 3, 0. Boom, just like that. Okay. And here we go, number 7. Ooh, look, it's the same as we did for number 4. So same idea. So what I'm going to do again, to get rid of these decimals, because it's like, what number, how many times does 0.7 go into 1.4? I mean, I guess we could just multiply by 2, but you know, that seems to throw people off. So let me just multiply everything by 10 to, you know, de-decimalize it. That's a word, guys, de-decimalize. Okay, so let's try this out. So our first equation is going to look like negative 14x plus 5y is equal to 24. Our second equation is going to look like negative 7x minus 7y is equal to negative 7. A lot of 7's going on here. All right, and so do you want to cancel out the x's or the y's? It looks like to me that I can, like, canceling the x's would be easier because I can just multiply the bottom number by negative 2. And that's it. I don't even have to do anything with the second equation or the first equation. So that's what I'm going to do. I'm going to multiply by negative 2. And remember why we do it with the negative 2, right? So that, because the negative 14 on the top equations are, the x on the top equation is already negative. So the bottom one has to be positive. So again, I'm going to just copy down the bottom equation there. And then I'm going to rewrite the bottom equation. So that's going to be positive 14x. It's going to be plus positive 14y is equal to positive 14. Are you positive? What am I asking? I'm like, yes, I am. And that's just, so the x's now cancel out. And 5y plus 14y is 19y. And 24 plus 14 is going to be 38. And we're going to divide both sides by 19. And we get, let's use this, y is equal to 2. And let's try this again. So we have the y. And so this time, so before I use the decimals, and this time I'm going to try using the ones where we got rid of the decimals. We de-decimalized it, right? And it looks like the bottom one looks a little bit easier. So I'm going to use that bottom equation right there. So negative 7x minus 7y. And remember, our y is going to be that 2. So we know what that is now, is equal to negative 7. So simplifying this down, we got negative 14 is equal to negative 7. And we're going to add 14 to both sides. It's two-step equations, what we've been doing. And it's going to be negative 7x is equal to 7, because negative 7 plus 14 is 7. And divide both sides by negative 7. And x is equal to negative 1. And so again, we're writing our point as our answer as a point, because it is a point. Remember problems 1 and 2, you know, that point, that solution, that's what this is. So if you were to graph these two guys, these two equations, they would meet right here at negative 1, 2. All right. So let's take a look at this guy right here, our last one of these. And again, all of these we've been solving with the elimination because they're all in standard form. I wonder why. All right. So if you take a look at these, none of these coefficients kind of go into the other one. So I'm just gonna multiply. I'm gonna get rid of the y's this time because I can just multiply by 3 and 5, which are smaller than 6 and 7. That's all. That was the only reason why. Let me do a little bit of don't go there. So the first one we're going to multiply by 5. Second one, we're going to multiply by negative 3. You need one of them to be negative, right? And so the top one is going to be, if I distribute the 5 out, it's going to be negative 35x plus 15y is equal to 125. The second one is going to be positive 18. Ooh, I almost said negative 18. Positive 18x minus 15y is equal to negative 57. Yes. All right. And now let's do some canceling out. So our y's cancel out just like we had planned. And we get a negative 35 plus 18, which is going to be negative 17. X, don't forget your X. And here, this is going to be 8, 11, 6, 68. And then we're just going to divide this, 68 divided by 17, which is just going to be 4. And let me see what let's use the screen. So divide by negative 17, divide by negative 17, and we get X is equal to negative 4. All right, don't forget that negative there. And when we plug it in, we're going to just plug it into the top or bottom. We'll use the bottom one. Why not? It doesn't matter which one you use, as long as you use one of them. So negative 6, instead of X, we're going to put in our negative 4. Just like that. All right. And then we have negative 6 times negative 4 is 24. Plus 5y is equal to 19. And then now we're just solving. So subtract 24. Like this is the same always and every day, always the same. And this is going to be 5y is equal to negative 5. And divide by 5, and we get y is equal to negative 1. Ooh. So which means our point is going to be negative 4, negative 1. Ta-da! All right, we have now finished We're almost halfway there, guys. All right, so we have 2 word problems. The first one is for number 9 is Horizon Cellular charges a $40 activation fee and a $25 monthly data plan. Whereas ACNC, I wonder where I'm getting these names from, charges a $70 activation fee and a $15 monthly activation plan. These are not real companies. I'm just saying they may reference them, but it's definitely not the right prices. All right, so here we go. Let's try these out. So for Horizon Cellular, Horizon, what's that going to be? So I notice here that there's an activation fee. How many times do we pay an activation fee? Just once, right? So this is, and I'm seeing something like, this is what I'm having to pay every single month. So in my brain, I'm thinking y equals mx plus b, right? That has a slope, which is like, oh, a recurring charge or something that's recurring, and then a one-time thing, right? This could be like, oh, every month you save $50, but in the very beginning, this would be our B. I put in a deposit of $1,000, whatever, right? So that would be like our B. So for Horizon, our $40 activation fee, that's our B. And our monthly plan, data plan, that's our M. So our equation will look like y equals 40x, haha, just kidding. Did you catch that too? M is 25, so 25x plus 40. Right, that's Horizon. What about ACNC? Right, so y equals, so it charges a $70 activation fee. So that's like our plus 70 right here. And a monthly fee of 50, so this is cheaper, but the activation fee is higher. So the question is, after how many months will the plans for both wireless companies be the same amount? Okay, if I'm trying to think about like what I want to choose, right? This might be something that I'm trying to do. All right, so if you notice here, they're both y equals. And if you remember what I said before, unless you skip through that part, is if they're in slope-intercept form, the easier way to solve this is substitution, where they're both equal to, if they're both equal to y, then we know that those things that are equal to y must be equal to each other, right? So here we go. So y, nope, just kidding. So since they're both equal to y, we know that 25x plus 40 has to also equal 15x plus 70, right? Because they're both equal to y, right? And so now we're just going to solve these. We're going to put the x's on one side. I like to get the smaller one and put it over on the bigger side, bigger x side. So I'm going to subtract 15 on both sides. And then I'm going to get, what is it? Let's use blue. That would be 10x plus 40 is equal to 70. Now, again, two-step equation. It always boils down to a two-step equation, right? So we're going to subtract 40 on both sides. And what do I get? That's going to be 10x is equal to 30. Now I'm going to divide both sides by 10. And I get x is equal to 3. All right. And then I'm just going to plug it back in. I'm going to use the bottom equation right there. But either one you use, it does not matter because it will give you the same answer. So 15 times 3 plus 70. So remember, we're using that 3 in for the x. So y is equal to, that's going to be 45 plus 70. So y is equal to, how much is that? 115. So we know, so make sure you're answering the question. It says, after how many months will the plans for both wireless companies be the same amount? So we're going to say, after, which one tells us the months again? Remember, that's the x, right? X is the one that we keep on multiplying with the monthly data plan amount. So x is the number of months. And y would be like how much it costs altogether, right? So total cost. So after 3 months, how both companies, remember this is including the activation fee. So both companies' plans would cost the same amount. And I'm just going to put in parentheses what that would be, which is $115. Done. All right, now we have an Xbox. So the Xbox Series X costs $500, and each game costs 40. Okay, I know that it is not every game costs $40, but for simplicity's sake, I looked at the prices and it was like, it was about 40-ish, give or take, right? And the PlayStation costs $300 and each game costs $65, right? So how many times do you buy an Xbox Series X? Like once you have the console, you don't like keep on buying it unless you do. If you're one of those, I don't know. So again, so the 500, this is going to be our B. And then the $40, because you're not going to buy just one game for the most, right? So we're just going to keep on buying games, because we need to change it up a bit. That's going to be our M. So for Xbox, so this is going to be Y equals 40M, 40X plus 500. Now for the PlayStation costs $300, and each game costs a bit more expensive, 65, right? So here's Y is equal to 65X plus 300. So it doesn't cost as much for the games. I guess that's where they're getting the money from, right? So this is going to be PlayStation. I'll just go PS5. All right. So if you remember, our X is, what is our X? This is where we define our variables. So our X is the number of games purchased, right? You don't buy the games. They don't cost you anything, right? The game is purchased. And the Y is going to be the total cost. Like how much do we spend on like this video game console and the video games, all that put together, right? All right, so again, these are written in slope-intercept form. So the easier way to solve this is by, what is it called? A substitution. So we know that 40x plus 500, we want it to equal 65x plus 300, all right? And I'm gonna bring my x to the right this time because I notice that 40 is smaller. So here we go. So we're gonna subtract 40x, and you get 500 is equal to 25x plus 300. If you were in class, we did this problem and I kind of made a mistake there. I made sure I didn't do that same mistake. And again, we're going to subtract 300 on both sides. And we're going to get 200 is equal to 25x. And we're going to divide by 25 on both sides. And we get x is equal to 8, right? Ooh, that means 8 games purchased. And what does that mean? We got to put it back into the equation. So we'll use the top equation just because, that's easier to multiply. 40 is easier to multiply 8 with, since I'm not using a calculator right now. And so put in that 8, this 8 goes right in there, plus 500. So y is equal to 320 plus 500. So y is equal to 820. So which means after purchasing 8 games, both game systems will have a total cost of $820. That's a lot of money. I wondered, again, this is not all at once because usually you don't buy games all at once, but 800, that's almost $1,000. That's a lot of money. Not gonna lie. All right, so for the next four problems, we're more than halfway there. Good job, guys. So we're gonna be writing this, what is it called? Just the inequality. So again, so we're looking at the y-intercept right here. That's going to be -5. So again, you're writing in this, I'm gonna put a little zero, like a hole there, because that's some inequality, right? And then, so it's gonna be mx plus b. All right, so we're gonna put in y. We don't know if it's greater than or less than yet, and we don't know our slope yet. We know our x, and then it's gonna be -5. Okay, that's my 1 point right here. That's, now, how do we find the slope? Well, I'm gonna look for another point on the line that's nice, like this one right here at 1, -2. And I'm gonna I start with the bottom one, and I can see, well, how much is it tilted? Well, I have to go up 3, it's like directions. Go down 3 blocks, or up 3 blocks, and then go to the right 1 block. Same thing. So 3 blocks up and 1 block to the right. So that's 3/1, which we would just say 3. So that's our slope right there. And then notice that all the y's, if you look at the y-axis, all the numbers are getting bigger, right? This is a little trick for that. So it'll give me greater than. Is it equal to though? You notice this line is dashed. So you wouldn't put an equal sign below that. That's it. Next one. All right, so we got y, we have x, and look at my y-intercept is right here at 2, so it's +2. Let's see. Oh, here's another point on the line right there. And I'm going to start with this bottom one. And I'm going up 1, 2, 3 blocks. 3 blocks up, so that's +3. And 2 blocks to the left, which means that's -2. So that's 3/2. The way we write that is always the negatives on the outside right there, just like that. We're going to go -3/2. And again, notice that the y's are going up. This way is the shaded areas, the y's are getting higher. So it is greater than. And is it equal to? Yes, because this is a solid line. So it can equal that line. So there's that right there. Done. Number 30, we're like cruising along. All right, so number 13, we're gonna take a look at this. So I'm gonna just set this up. So I got y and then the x. My y-intercept is here at 2. So it's gonna be +2 like this. Another point on the line. Oh, this looks like it's a point on the line. So we're gonna go up 1. That's +1. And then to the right, how many? 4. So that's +4. So that's gonna be 1/4. And if notice, I wasn't sure about that, so I'm gonna try that one more time. So I'm gonna go up 1, to the right 1, 2, 3, 4, and yes, I do end up on the line again. So I'm good to go. That's one way to check. If you're uncertain, just try to do that same slope again and see if it gets you a point on the line. If it doesn't, then you're a little off. Okay, and you need to find another point. Again, this is going, why are these all going up? What was I thinking? Okay, so this one is going up as well. So this is, again, going to be greater than. Is it equal to? No, because it is a dashed line. So this is what it's going to look like. All right, and for the last one, right here, this is at -3. So y, something x, and then -3. Slope, let's take a look. Looks like right here is the next point. So go up 2, so that's +2, and 1, 2, 3, 4, 5 to the left. That's -5. So if you're not sure, I'm just gonna go, I can't go another up 2 and over 5. I'm gonna go down 2 and then to the right 5, and I do end up on a point on the line, so I'm good to go. So again, that's gonna be 2 over -5, which we write as -2/5. And again, this is greater than. I don't know why, what was I thinking? And again, it can equal because it is a solid line, just like that. All right, I think I was overthinking the whole situation here. But yeah, but if it was shaded below, then it would be less than. Just saying. All right, so here now we actually have to make our graphs. So let's try these out. Last 4 problems, people. All right, again, we're going to start with the 3. This is our y-intercept right here. So we're going to go at 3. Our slope is 1/2, but it's one of them is negative. So I'm going to go up +1. And since I went +1, I'm going to go to the left 2. So up 1 to the left 2. I'm going to do that. You technically don't need this many points, or you can go down 1 and to the right 2. Either way, so this is our negative slope like this. This just is going to help me draw this line better. It is going to be a dashed line because there is no equal to sign underneath there. So it's going to be dashed like this. This technically can't equal this line. Now, again, we're going to think about the graphing or the shading. And if you notice right here, y is less than. So this is where we would actually shade below. I am not, you can see that I'm not actually shading anything. I'm just drawing lines because I'm looking for the overlap. So that's not technically our answer yet. Okay, if there was only just one inequality, that would be our answer. But we want, like, what's the overlap of the 2 inequalities, right? And so my other one, I'm going to make red. So again, here we're going to start at -6. So we'll go down to -6. And then our slope is -2. I like to put a little over 1 there because I need the run part. So I'm going to go down 2 and then to the right 1. Then down 2 to the right 1. Or you can go up 2 and then to the left 1. Either way, it's still going to be on the same line. And is this going to be solid or dotted? It is definitely going to be solid because of that line underneath. It can equal it. So here is our line, just like this. All right, and it says x, the y is greater than. So it's going to be pointing, it's going to be going up. So if you notice here, this graph has been cut, or this coordinate plane has been cut into 4 different pieces, right? So we got the lower left, the upper right, and lower right, right? And where is it pointing to? Where are both lines pointing to? You notice here, it is definitely pointing to this lower right section right here. So this is what we would graph. Okay, oop, don't want to go over the lines. This is where you don't want to color over the lines. So here we go. Stay within the lines, peoples. Okay, so it's all this guy right here. Okay, that's how you shade that, and that's the solution. Okay, we're going to try this 3 more times. Again, our y-intercept is here at -7, so we're going to go to -7. Our slope is 4. Remember, that's 4/1. So we're going to go up 4, 1, 2, 3, 4, and over to the right 1. Keep on doing that. And this is going to be dotted because we don't have an equal sign underneath that. We are going to be shading lower than because it says y is getting smaller. So y is less than. We're going to go this way. Again, we're going to take a look at the second one. This is +5. Go right here to 5. And then this is -2/1. So we're going to go down 2 to the right 1. Down to the right 1. Down 2 to the right 1. And is this going to be solid or dotted? I hope you said dotted because there's no equal to sign underneath that. It does not include this line right here. Right, it's just a boundary here. And it says y is less than, so we're going to go less than. This is where y's, see, notice the y's below are getting smaller. So this is less than. So where is the section getting the overlap? What section is both of them pointing to? And it's going to be this one right here. Where it's below the brown and below the red. All this guy right there. All right, good job for those guys who persevered through the end. Good work, peoples. All right, so we got here. This is 4. Can't even talk anymore. So here it's going to be at 4, and our slope here is -5/3, which means we can go up 5 and to the left, because left means negative, or down 5, which is the negative, and then to the right 3. So here we go. I'm going to go up 5, 1, 2, 3, 4, 5. And then to the left 3, 1, 2, 3. I'm going to just go the other way 2, 1, 2, 5, and then 3. And it should all be 3, 4, 5, and then 3. And it's going to be solid or dotted. And it's going to be dashed because it is not, there's no equal to sign underneath it. All right, and it is y is less than, so we're going to go below. All right, and we're going to try this one. This is going to be -4. So we're going to start at -4. But here's the problem. I don't have a number there. What happens if there's no number there? Remember the number that's in front of the x if there's no number there? It's like the given. Yeah, it's a 1. So 1 over 1. So we're going to go up 1 and to the right 1. Up 1 to the right 1. So it's going to look like this. Again, you don't have to do all these points. I just do it so that I can make a nice line. And here we go. And it is equal to, so that means it's a solid line right there. Because the graph can't equal that line. The solutions are also on this line. And it says y is less than. Ooh. You notice here that I have a lot of less thans. Bad day right there. Bad planning on my part, sorry guys. But you get the picture, right? So it's all this guy right here, the less thans. All right, last one. You ready for this? I hope you've been trying these yourselves. All right, so here we go. -6 is our y-intercept. Our slope is at -1/2. So up 1, to the left 2. Or down 1 and to the right 2. And that is going to be less than or equal to, which means that it is a solid line like this. Less than means lower than. Again, if it was greater than, it would be above, right? But it was lower. Let's try this next one. So this is going to be -1. Slope is 3/4, so that means it's +3, 3 up, and then 4 to the right. 3 up, and then 4 to the right. Or both are negative, you know, because the negatives cancel out. 3 down, and then 4 to the left. 3 down, 4 to the left. And in this case, this is going to be dotted because there's no equal sign underneath. So here we go. And then again, this is going down because it is less than. So what is everything pointing to? The stuff down here. All right, so that's the end of the review. Rewatch parts where you need to. Please practice and try to do things on your own. And if you get confused again, go back and rewatch it again. All right, I'll see you later. Good luck. Do well. Bye-bye.